So let's go ahead and practice some of these here, and let's do 10 to the power of 2 to the power of 3. So with this one here, we can use our rules with powers of powers where we're multiplying these two here, or you can see the expanded form helps us out a little bit on this one as well, where we get 2 times 3, which is 6, so we get 10 to the power of 6. Next up, we get 10 to the power of 2 to the power of negative 3. Now again, I know we just looked at this one here, but what we do here is when we have a power of a power, we're multiplying these two numbers. 10 to the power of 2, 2 times negative 3 gives us negative 6. And you see in the expanded form here, 1 over 10 times 10. If we multiply this out, you get 1 over 10 to the power of 6, which is the same as 10 to the power of negative 6. Next up, 10 to the power of negative 2 to the power of 3. Same idea as the last one here. We have it multiplied out in expanded form here, or we can use our power to a power rule, where we're taking 10 to the power of negative 2 to the power of 3, which again gives us 10 to the power of negative 6. Lastly, we got 10 to the power of negative 2 to the power of negative 3. And this one here, again, multiplying the powers of powers. The expanded form doesn't help us as much here, which is why the rules are really nice, because dealing with something that looks like this with all of these fraction bars makes it a little bit difficult. So in this one here, I'm going to use my rule to make it nice and easy for me, because I can just multiply these two numbers. Negative 2 times negative 3 is a positive 6. So our final exponent is 10 to the power of 6. Next up, let's go ahead and use our rule for dividing power. So we have 10 to the power of 2 over 10 to the power of 5. Expanded form is nice here because we can cancel these out and see it this way. But again, let's use our rule to help and make sure that we know what our final answer is for a single exponent, because we can take the numerator's exponent and subtract the denominator's exponent, which gives me 10 to the power of 2 minus 5. 2 minus 5 is negative 3, which gives me 10 to the power of negative 3. Again, if we use the expanded form, what we'd see is that it would be 1 over 10 to the power of 3, which we know is 10 to the power of negative 3. Next up, 10 to the power of 2 over 10 to the power of negative 5. Same idea here. The expanded form, though, doesn't help us a ton because it's kind of confusing with all these fraction bars, but we can use our rule of dividing exponents to see 2 minus a negative 5. And when I'm subtracting a negative, it's like adding a positive. So it's 2 plus 5, which gives me 10 to the power of 7. Next up, 10 to the power of negative 2 over 10 to the power of 5. So again, the expanded form isn't as helpful, maybe gets a little bit confusing, but if we use our rule where we are subtracting when we are dividing powers here, we have negative 2 minus 5, which gives me negative 7. So that tells me that the final exponent here is 10 to the power of negative 7. Next up, 10 to the power of negative 2 over 10 to the power of negative 5. Again, expanded form, not helpful. So 10 to the power of negative 2 minus negative 5. So 10 to the power of negative 2 minus negative 5. That's like adding a positive 5, which gives us positive 3. So our final answer here is 10 to the power of positive 3. Last set of problems here, let's go ahead and use our rule for multiplying powers. So we have 10 to the power of 4 times 10 to the power of 3. Remember, when we are multiplying powers here, we can add the two exponents. So 4 plus 3 is 7, so that tells us that our final exponent here is going to be 10 to the power of 7. You can also see it in expanded form. Next up, 10 to the power of 4 times 10 to the power of negative 3. So again, we are adding exponents when we are multiplying like bases. So 4 plus a negative 3 is just 1. So we could either say 10 to the power of 1, or we could just say 10. Expanded form here, if you actually multiply it across, you'd get 4 10s on the top and 3 on the bottom, which leaves you with 10 over 1 after you simplify. Next up, 10 to the power of negative 4 times 10 to the power of 3. Same idea here. If you use expanded form, you could multiply across and then simplify, or just use our rule of adding these two. Negative 4 plus a positive 3 is negative 1, so that gives us our final exponent of 10 to the power of negative 1. And lastly, 10 to the power of negative 4 times 10 to the power of negative 3. And again, using expanded form, we would see that it's 1 over 10 to the power of 7. Or if we used our rule here, we'd add these two together to get negative 7. So remember, 10 to the power of negative 7 is the same as 1 over 10 to the power of 7. That's all I got for you here, people. So if you have any questions, make sure to reach out. It's important to know that when we're dealing with negative exponents, it's like saying, that they are on the denominator with a numerator of 1. So if we have 10 to the power of negative 1, that's like just saying 1 over 10. If we have 10 to the power of negative 7, that's like saying 1 over 10 to the power of 7. So again, we're kind of flipping the positive and negatives of these exponents here and making it into a fraction. But also, an important thing to see is that we can use these rules even if we have negative exponents. So if we have negative exponents, we can still multiply and add the exponents. We can use the dividing rule and subtract the exponents, and we can use the power of a power rule. All right, people, if you have any questions, reach out. Otherwise, be good to each other, and I'll talk to y'all soon.